And we are welcome Clara from Sirius. Yeah, so the floor is yours.
So good morning, everyone. I am Ana from the Brazilian Synchrotron Light Source on behalf of the Sirius team. I am from the control software group. I'm the leader of the group since the end of the last year. So, but I am in the CNPM from since 2017. I used to be accelerator, high-level software development, so software developer, and I am in the control software for Beamline's award in this year. So it's quite a short time in this experience. So in my talk, I will present you a short overview of Sirius, about some introduction to the current status of Sirius Beamline acquisition tools and our initiative with the Blue Sky package, and mention our next steps in this direction. So about Sirius, we have a fourth generation synchrotron light source with we are a greenfield facility. We started the commissioning of the accelerator in 2020, and we are operating with regular users since the end of 2022. We are operating with 100 milliamps, in a top-up mode. And just a curiosity, now we are in a shutdown maintenance to RF cavity upgrade. So now we are in Sirius phase 1. So we now operate 10 beamlines, and we have some more in commissioning, construction, and installation phases. So just briefly mentioning some future challenges. We will have 3 of our beamlines integrated to a new laboratory of biosafety laboratory of level 4. So this will come with the Orion project. It's a new project of CNPM. About the current status of our beamlines. Our control system is based on EPICS framework. So in our beamlines, we have, for acquisition, we have, for control and acquisition, we have some tools based on PyEpics library. Several of these tools are implemented by the Beamline staffs. So they use PyQt, PyDM, combined with some Python logic there for both control and acquisition. We have some Jupyter notebooks too. These tools have made possible the users to access our facilities, but there are plenty of room to improvement. So in this scenario, we started to study the Blue Sky packages to improve this scenario. So some common challenges between the beamlines were experiment downtime to the software issues, lack of modular, standardized, and shared solutions between the beamlines. So each Beamline has its solution, so it's missing some shared solutions. There are difficulties in managing experiment metadata, and some problems with acquisition robustness. So our strategy was to start developing some modular and standardized solutions, and use some community shared solutions. So we had some good experience in ad hoc solutions using Blue Sky in 2 of our Beamlines in operation. So since the beginning of this year, we have experimenting with several Blue Sky packages to solve the problems I mentioned. So we decided our first step was to build some solutions on top of the OFID hardware abstraction layer and the Blue Sky orchestration layer from Blue Sky, and we are developing some packages in a family of packages we called SOFIs, series of OFID and Blue Sky utilities. And we have 2 parts of this. The first one is the common SOFIS common package. In this part, we put our common devices, common plans, some generic utilities, for example, some registry tools for the hardware devices. So generic callbacks, Kafka interaction, some specific devices for Sirius. So we provide this as a common package for all the Beamlines. And for each Beamline, we have a package where we put some very specific very specific devices and dedicated plans. And in this package, we also managed how to handle the metadata of each Beamline. So in this way, we managed to develop the hardware orchestration and the hardware abstraction. So it's a centralized way to see the possible downtime software problems. So it's working for now. So this package solve some of the problems I mentioned. So the standardization, so the downtime problems, and the metadata. The last one, robustness, to explain I think it's good to explain the context of our Beamlines. So each Beamline has some dedicated servers where we run some services and IOCs or other device, hardware devices stuff. And for the users control, we have some workstations where the servers are designed to be more reliable, have high availability, and more computational power. And the workstations for each user are not designed to be very computational have computational power. So in these workstations, we run some control GUIs and some Python scripts. But the problem was the acquisition routines was designed to run in this workstation. So it depends on a user session and on the, so that's it. So and we wanted to solve this, and we in this context we tried to move the acquisition to client server architecture. So we are using the Q server from the Blue Sky to run the run engine, and in the Q server of each Beamline we configure our dependencies, the soft common and the Sofis for each Beamline. We also are using the HTTP server for authentication, and we have a Kafka service for each Beamline. And this is the configuration for each Beamline. And we are thinking about, we are implementing now some Sofis clients to communicate with these services. So for some clients, we are working now with some solutions. For the first solution we worked on, it was in a desktop GUI that uses Blue Sky widgets package, and it has also a Kafka consumer there. So by using this application, the users can interact with the Q server and put some plans and parameterize the plans and see the history and the current plan that's running. So you can stop and start an environment, and it can it's possible to see the documents data through some graphics. And we are also working in a client that it brings a spec-like experience that we called Sophiscally. It's a solution that implements an access through the HTTP server, so it has an authenticated access to the Q server. It uses some IPython magics, and it has also a Kafka consumer. So we bring an experience of Linux terminal commands to trigger some scans through the Q server, and it's also possible to see the data and to connect with Blue Sky callbacks through Kafka. So it's an okay. And with this architecture, client-server architecture, it was possible to think about some external access through web clients. So we are starting an exploration in a Sophie's web client, and the idea of the Sophie's web is to apply some modern web technologies in a solution. So we use TypeScript, React, Next, TRPC, and React query to handle API roads, and we use ShadCN for components or for front-end components, and server-sent events to communicate with data stream, just like Kafka and HTTP server. And we are working in a monorepo solution with some common packages with UI components and some other utilities to be shared between each Beamline application. We are now working in one application for proof of concepts. So in our next steps, I can mention we have just started all those initiatives. So we are working closely with the Beamlines to get the right requirements and map what improvements are needed. And we are working with the data management and science group discussion ways to integrate to the Nexus converter that they have the assonant with the Blue Sky documents. So I would like to thank my colleagues for helping me with this presentation, and thank you for your attention.
Thank you, Anna. So there is time for a very short question.
Does your HTTP server handle individual user authentication?
Yes.
Okay. Short question.
Thanks again, Anna.